All right, so what we're going to do is we're going to do some more examples from 12.3 and kind of give you an idea how things are working and keep up on how we're doing things here. So what do we have here? Well, we're supposed to find the vertex and the extreme value of the function. So remember, depending on if a is greater than 0 or less than 0, so a greater than 0, that's going to open up, and when it opens up, we get a minimum, and if a is less than 0, it opens down. And so when it opens down, we're going to get a max. And remember, the y value is the extreme value. So whether it's the max or the min, it's going to be this extreme value. So what that means is we have to find the whole vertex. And that's why it says find the vertex and the extreme value. So for this one, what is the vertex? Well, we're going to have a minus 5 over 2 times 2, because it's minus b over 2a. All right, so minus 5 is 5 all over 4. And so that's going to be our x part of the vertex. Now, what do we have? Well, now we have to find what is f of 5 over 4. Well, that's going to be 2 times 5 over 4 squared, and then minus 5 times 5 over 4, and then minus 4. And so let's go put that into our calculator because it's going to be easier. And so what we have is we're going to have the 2 times 5 divided by 4 squared. And then we had minus 5 times 5 divided by 4. And then we had minus 4. And now I'm going to say, well, let's do a fraction so I know what the fraction is. And so that's negative 57 over 8. So this is negative 57 over 8. All right, so that's my vertex, and the extreme value equals negative 57 over 8. Now, because it was a greater than 0, this is a minimum extreme value. Okay, so that's the key thing. It's a minimum extreme value. But we have our vertex, which we needed, and we had that extreme value. All right. So moving on from there, again, there's only 3 types of problems they present in our book. And so we have the rocket launching, we have a cost function, and we have a revenue function. So that's the 3 we're going to look at. And with this one, we have a is less than 0, so it opens down. And so because it opens down, this is going to be a max. So we're going to have a max probably height in this case. So what it is a rocket is launched at t equals 0 second. Its height in meters above sea level as a function of time is given by this function. And at what time does the rocket reach its maximum height? Well, remember, this is going to be time is x, and then the height is y. And then at what height does it reach its max value? Round your decimals to 2 places. All right, so first we have to find the vertex. So minus b, which is minus 223, over 2 times a, which is negative 4.9. All right, so now we have to plug all that into our calculator. So let's clear that out. So it was minus 223. Oops, where'd the answer come from? Minus 223 divided by 2 times negative 4.9. And we get 22.75 to 5, but to round to the nearest hundredth is 76. So that was equal to 22.76. And again, the time, so that's in seconds. Okay, so we have 22.76. And then we want to find h of 22.76, and that's equal to negative 4.9 times 22.76 squared plus 223 times 22.76, and then plus 129. And so now we get to plug all that into our calculator. And so we had a negative 4.9 times 22.76 squared, and then it was plus 223 times 22.76, and then it was plus, and then I think it was 129, and so 2666.19, and then the 3 won't round that up, so 0.19. That's going to be our height. And so that was 2666.19, and we're in meters. And so that would be what our y was. Okay, so that's our vertex, but it's 22.76 seconds and 2,666.19 meters. Okay, so those are the two question answers we're looking for. This is for A, and this is our height. We reached that in 22.76 seconds. All right. What about the next one? The next one's a cost function. All right, so here, before we read it, we see that A is greater than 0, so it opens up. Well, that means we're looking for a minimum, okay? So we have a cost function C of x of producing x totally cool coolers is modeled by the function given. And how many coolers need to be produced and sold in order to minimize that cost? And what is that cost? All right, so again, it doesn't tell us what decimal place they're around to. So, you know, if we use the actual value, if it's a half a cooler, then we'll get a funny number, but hopefully we'll get whole numbers. All right, so minus 0.25 over 2 times 0.005. All right, so we plug that into our calculator. Let's clear that out. So we have a minus, so it's just going to be 0.25 divided by 2 times 0.005, and we get 25. So we get 25 coolers this time. All right, so 25 coolers. And so we have 25 comma, and remember it was coolers comma cost is how our function is set up here, because x is number of coolers and then y is c of x, which is cost, and so it's coolers comma cost. So now we need to find c of 25, and so it's 0.005 times 25 squared minus 0.25 times 25, then plus 12, and plug that into our calculator, and we'll put it to the nearest penny. And so what did we have? We had 0.005 times 25 squared, and then it was minus 0.25 times 25, and then it was plus 12, and so 8.875, which rounds to 8.88. So this is where's my pen? There it is. 8.88, and so that's what this would be. Again, coolers cost, so $8.88 and 25 coolers. So that's going to be minimizing the cost and minimizing that with 25 coolers. All right, revenue function. Okay, well here again, we'll look at our value here before we start. So here A is less than 0, so it's going to open down, and so we're going to look at some kind of a maximizing problem. And with revenue, you want to maximize revenue. Cost, you want to minimize costs, so it kind of makes sense. So the revenue of producing and selling X awesome hearing aids is modeled by the function given there. Now, how many hearing aids is needed to be produced and sold in order to maximize that revenue? So last time, remember, if you watched the first video, we ended up with half a hearing aid, and so we rounded up. So let's see what we get on this one. Maybe we get a whole hearing aid and we don't have to round. So we're going to have a minus B, which is 105, over 2 times A, which is a negative 5. So if we do that, 105 divided by 10, well, that's 10.5. So we don't get a nice number again. And so we could do it, we're going to do it both ways. We're going to have 2 here. So 10.5, and we're going to do 11, because we know that 11 is going to be how we're going to actually have to do this. We're not going to be able to make only 10.5 hearing aids. We're going to have to go to 11 hearing aids. And so then what we're going to do is we're going to take R of 11 and get a -5 times 11 squared plus 105 times 11. And we're also going to try it with R of 10.5 just to see what kind of difference we are looking at like we did kind of last time. All right, so calculator. And so we have -5 times, let's do 10.5 first, and squared, and then plus 105 times 10.5. And so that's 551.25. So that would be our ideal case scenario. But what we really found, if we round to the whole hearing aid, we'll get 11. We round the next one to the whole hearing aid again of 11. We get only 550. So we're losing $1.25 here and half a hearing aid. So, but that's again, that's just how things work. So for this one, we had 550, and this one we had, what was it, 551.25. So 551.25. 550. And so, that's kind of the difference between the two. And again, making whole hearing aids is going to be the key here, or whole coolers, or whole something. So that's going to be the best way to do it, is go ahead and round it up to the next number. And so that would give us the 550. If for some reason you put the 10.5, then of course your revenue is going to be a little different as well. So I think that's all I have for you on this one. Hopefully that will help.